So I actually want to start by going over a little bit of history. First, where did the name Gazelle come from? So within Google, there was a tool called Glaze. Glaze would generate build files for Go packages, one directory at a time. So you generally run Glaze. It would read all the Go files in a directory. It would read the package names and imports, and it would translate the imports to the Bazel, the Blaze labels within Google 3. And then write out the build files. And it could do that very quickly because Google 3 had a very strong convention mapping import strings to labels. Like things had to be in a certain place. So Glaze could actually run in about 50 milliseconds. And as a result, people would configure their editors to just run Glaze whenever they saved a file. As a result, a lot of Go developers didn't even think about build files. Like they just never opened them. You'd just be able to write your code, save your files, run your build commands, see your test pass, and so on. Just like a whole layer you could just totally forget about. I'd really love Gazelle to get to that stage, but the world outside Google's monorepo is much more complicated, so we have a ways to go. So some more history. Gazelle was first introduced in 2016 by Yuki Sanada. It was used to fetch external Go projects. I've never met her, but I hope she's pleased with everything that we've done since then. I joined the Go tools team in 2017 along with Ian Cottrell, and we worked on Rules Go and Gazelle together to improve the developer experience for Kubernetes. At the end of 2018, I added Gazelle's extension interface, so we were able to pull protobuf and Go outside of the core and support other languages. And we got our first other language in open source in 2020, so adding Bazel library targets. So thanks to Andrew Allen for adding that. In 2023, Gazelle gained support for Bazel mod, which is actually simpler than dealing with workspace, so I'm very happy for that. And this year, we have Gazelle 2.0 proposal and lazy indexing. So before we get to lazy indexing, I want to go over kind of a mental model of how Gazelle works. So you can run it either in single directory or across an entire repo. We'll just talk about single directory today. And so the first pass is it parses your build files, and it reads your source files, and it reads the configuration, and it figures out what rules it thinks should be there. And it merges those in memory with any existing rules in the build file. And as part of this pass, it also builds an index of all the library rules in the repo, and it needs to read all of the build files in order to do that. And so in the second pass, it does dependency resolution using this index. So it will map the import strings of each language into Bazel rules. It will set the depths attribute of each generated rule. It merges again, formats the build file, and writes it out. So I mentioned Gazelle needs to index all the build files in the repo, and yeah, as you might guess, that's kind of slow, and it seems really slow if you only edited one source file. You expect a small change to have a small impact. So it varies a lot. For Kubernetes back in 2018, it took up to 30 seconds. So this was obviously a source of friction for them. They didn't quite like Bazel because of this and a few other reasons. Computers are faster now. Gazelle is faster, but take that number for what it is. Within EngFlow, we have a fairly small repo. It still takes about 800 milliseconds. Cockroach Labs, more optimized, larger open source Go repo, 150 milliseconds, not bad. Uber's monorepo, 25 seconds. So they have a very large repo and a lot of extensions. But obviously, it is a source of frustration. So why did we do indexing this way? Glaze didn't need any indexing at all. It could just look in a directory, didn't need any more context than that. But as I said, the world outside Google is complicated. So before Go modules, you could have Go vendor directories pretty much anywhere. So there wasn't a one-to-one correspondence between import strings and Bazel labels. And protobuf was even worse. So you could have your directory of proto files anywhere, but each proto file can declare how it wants to be imported, like what import string, what class name it should generate, and so on. So not only did Gazelle need to know something about the repository structure, but it also needed to read the file contents to see how something should be imported. So indexing solved that problem, full indexing solved that problem, and most open source repos were small enough that it was kind of an acceptable trade-off, only marginally so for Kubernetes. But we can do better, which leads me to lazy indexing. So most directories, most import strings have some structure. So even though we can't do a purely textual transformation, we can generally have Gazelle index a small number of directories when it sees an import string. So let's say we're in module example.com/m, and we're importing example.com/m/foo/bar. We would like Gazelle to just read the directory foo/bar and see if the library is there. Or say we're importing another package outside our module, example.com/p/q. Gazelle should look in our vendor directory. That's where we would expect to find that. So that's an easy case, the common case. What if you have a vendor directory with a non-standard name? So in EngFlow, we have third-party Go, third-party Java, and so on. We can tell Gazelle about that with a Go search directive. So this just adds a directory to a search list. So now when we import example.com/p/q, Gazelle will look in third-party Go in addition to our vendor directory. What about something narrower, a little bit weirder? Maybe we created a fork of our dependency, example.com/p, and we put it in a directory that doesn't have the full name, fork/p. So this Go search directive can strip the prefix for you. So this says that if an import has the prefix example.com/p, then look in the fork/p directory without that prefix. So how does this work? Well, Gazelle needs some language-specific intelligence. So each extension needs to support this by returning a list of directories to index through this new rels to index field. That's based on the import strings that are seen in source files. So each extension can define a search directive like Go search. We also have proto search and CC search. They have a little bit different syntax that's better adapted for those languages. And once you have all this, then you can run Gazelle in a single directory with the flags index equals lazy and r equals false, and that disables recursion. And then Gazelle only indexes directories that it was told to update, plus the directories requested by extensions, plus their parent directories, because Gazelle needs to read some configuration out of the build files anyway. So that's a lot fewer build files to read than the entire repo. So this generally saves a lot of time. And in addition to this, as part of the optimization work, Gazelle now reads directory metadata in parallel with multiple threads, and it caches everything in memory. So we don't do a lot of redundant I/O. So thanks to Jason Bedard for doing that work. That's enabled whether or not you're using lazy indexing, and it sped things up quite a bit. So with those changes, Gazelle now runs considerably faster in most repos with very little additional configuration. So with a few Go search directives and EngFlow, we got it down to about 100 milliseconds. And Uber went down to 352 milliseconds, a 99% improvement. So they're still working on this. There are more extensions to adapt to this, but it's very promising. I should add these numbers are with Gazelle run directly. If you run it through Bazel run, that adds 500 to 1,000 milliseconds of overhead. So take that into account. Well, why does this matter? Speed is really important to me. I'd like to convince everyone that speed should be important to you too. It's an important feature for interactive tools in particular. It changes how we use our tools, and it changes how we feel about them. It keeps us productive and focused. So if something takes 50 milliseconds, like Glaze did, you can just run it every time you save a file. You don't even have to think about this whole thing. And if it takes 10 seconds, well, you run it when you have to, like if you add a new file or something. If it takes 100 seconds, you'll only run it in CI to validate your changes, but you're going to do most of your edits by hand. And if it takes 1,000 seconds, well, it's probably not worth running at all. So if a tool is fast, you'll use it for more things. It's actually more useful. What comes next? Well, we'll add support for lazy indexing to more open source Gazelle extensions. So it's in Go, Proto, and C++ already. If you maintain an extension and would like to add this, whether it's public or private, talk to me. I'd love to help. We have some documentation on how to write an extension, and there's a section in there for lazy indexing. So that's in extend.md in the Gazelle repo. And I mentioned in the keynote that we're working on a proposal for Gazelle 2.0, and one of the proposals in there is to turn lazy indexing, turn that on by default. So hopefully you'll be seeing a lot more of this. So please try it out. Let us know how it goes. That's it. Thank you, everyone.